Right, this is the electronics and photonics section. We start off and we've got 4 resistors here and they're 2 ohms each. The first question is, show that the total resistance of the circuit between X and Y is equal to 3.3 ohms. So they've given us the answer and we had to show the working to get there. One of the big mistakes with this one was how the circuit looks. But I'm going to redraw the circuit to make it seem a little easier. So X comes along and the first thing it goes through is A. That's A. After it's gone through A, it comes to this junction here. And I'm going to redraw my junction like this. It's still a junction. I've just sort of opened mine up. And on one side of the junction we've got B. And on the other side of the junction we've got C and D. And then it comes out of B, comes out of B, comes out of D, down here, and those meet up again. And there's Y. Now that seems a lot easier to deal with than that one, for my students anyway. So now it just says find the total resistance of that. So what I'm going to do is I'm going to do this part first, then I'm going to do all of that second, and then I'm going to add in the A third. Okay, so one, we're going to do C and D. So because they're in series with each other, and they've got 2 ohms each, it's just the total resistance equals 2 plus 2 equals 4. Alright, now I've got the equivalent of a 2 ohm here and a 4 ohm here. This is my 2 ohm here, and I've got these in fourths. This is my parallel. It's in parallel, so I've got to go 1 over R total is 1 over 2 plus 1 over 4. Right, I've got to make the bottoms the same, so the common denominator is 4, so this one becomes, I double this, so I get 2 over 4 plus 1 over 4, okay. And that is 3 over 4, which is 1 over RT. Then I've got to flip it, so RT equals 4 over 3, which if I did on my calculator is 1.33 ohms. That's my first section here. I've done my second section here, and then my third section is, I've just got this last one to add, which is in series with the last bit of parallel, so I just add it. I just say 2 ohms plus 1.33. And that equals 3.33 ohms. And that's what they were looking for. Alright, they add in a 10 volt battery. What's the current through resistor B? What is the current in resistor B? I and B. What I'm going to do is I'm just going to redraw this over here, make it a little bit easier. Similar to what I did before. We've got A, we've got B, and I'm going to put C and D around the corner so you can see that both in that parallel. Hopefully this will make this this a little bit easier. There's A, B, C and D. Alright, there's 2 ways to go through this. The first way is I want to know the current in B, and the formula I use is V equals IR. So if I want to know I, it's V over R, and R is V over I. If I want to know I in B, it must be the voltage in B over the resistance in B. I've got the resistance because that's 2 ohms, they're all 2 ohms, but I don't know the voltage. Alright, so I need to work out the voltage. I'll tell you what, if I work out the voltage in this arm, it's going to be the same as the voltage in this arm, and they're going to be the same. And I know there's 10 volts total. A is going to use some, so whatever is in each of these arms is going to be 10 minus the voltage in A. It's going to be the voltage in that, and it's going to be the voltage in that. So if I can work out the voltage in A, I'm pretty happy. So that's what I'm going to do first. How do I go about doing that? Well, the voltage in A equals the current in A times the resistance of A. I've got the resistance of A, that's 2 ohms, but I don't have the current in A. Oh, far out. Alright, let's try again. It turns out the current that comes out of here is the total current. It then splits up along here. So if I can work out the total current, that's the current in A. And the total current is voltage over R. I'm just putting these little labels on them so I know it's total. Total voltage over total resistance was 10 volts divided by 3.3 amps. That on my calculator is 3.3 ohms. That's what I worked out in the first one. Gives me 3 amps. So that's 3 amps comes out here, goes through there. Now I can do this. I can say the voltage in A equals 3 times 3 amps times 2 ohms, which equals 6 volts. So now I've got this as 6 volts. 6 volts. So there must be 4 volts left over for this, and 4 volts left over for these guys. Now I can do my last one. I've written them all out and now I'm working backwards through them. Let's do it up here. The current in B equals the voltage in B over the resistance in B, which equals 4 volts over 2 amps. 2 ohms, which equals 2 amps. Is my answer. That was Y1. Y2. What I'm going to do with Y2 is I'm going to work out the total current, which is the total voltage over total resistance. We've done this before over here, which is 10 over 3.3, which is 3 amps. So 3 amps, again we've got 3 amps along here, 3 amps goes along here, and then it splits up. Some of it goes this way, and some of it goes this way. 2 ohms is 4 ohms in here, and there's 2 ohms in here. This is harder for it to go this way, and it's easier for it to go this way. So the current that goes down B is therefore going to be twice as much as the current that goes down through C, because resistance is half. Okay, the resistance in this arm is half of the resistance of this arm, so it gets twice the current. If we've got twice the current here that goes in here, and they have to add up to 3, this must be 2 amps, this must be 1 amp, because 2 plus 1 equals 3. Same answer. Alright, I've copied and pasted the picture again. What's the voltage drop across A? We've already done that, but we'll do it again. The voltage across A equals the current in A. I just use V equals IR, but to make it really easy, I put these subscripts on them, and it makes it really easy to know what needs to go in. So voltage in A equals current in A times the resistance in A. But the current that comes out of here, the total current goes through A, so that the current through A is the total current. And the total current we've calculated before was V total over R total, which is 10 over 3.33, which equals 3 amps. Therefore, the voltage in A equals IARA equals 3 amps times 2 ohm equals 6 volts. And the last one is, what's the power dissipated in resistor D? So I've got a couple of formulas. Power equals VI. Power in D is the voltage in D times the current in D, or power in D is the voltage squared in D over the resistance of D, or the power in D equals I squared D times R of D. We could pick any one we wanted because now we've got so much information about this. We know this uses 6 volts. 10 minus 6 is 4 volts in each arm, so there's 4 volts in this arm, and there's 4 volts over both of these. So there's 2 volts each. We know the resistance of, we're looking at D, we know the resistance of D is 2 ohms. We also know the total current equals 3 amps, and in the last question we saw that it splits and 2 amps goes this way, and 1 amp goes this way. So we've got the voltage, the resistance and the amperage through there. We could use any one we want, so let's just use V equals IR, this one here. So it's 2 volts times 1 amp is 2 watts.